Let us see in detail about control of gases contaminants or gases emission control. Depending upon the properties, there are different methods are adopted. In your syllabus, there is only 3 methods are discussing. The first one is adsorption, second one is absorption, and the third one is thermal methods. So let us see in detail about each one of the methods. Absorption method. The pollutant gases are passed through absorbers, which contains liquid absorbents that remove the pollutants in the gas stream. In other words, the pollutants from the dirty gas get absorbed in the liquid through which the gas is made to pass in these units. This absorption unit work on the principle of transfer of pollutants from the gas phase to the liquid phase. The efficiency of this machine or this control device depends upon various factors. First one, amount of surface contact. There is two phases are there, PHASE phases are there, gas phase and liquid phase. So the amount of surface contact is very important. Then second one is contact time. The same time, concentration of absorbing medium. The last one is speed of reaction between the absorbent and the gases. Mainly the water. Water is the most commonly used absorbent liquid. So this absorption process, gases pollutant is dissolved in a liquid. Absorption units include spray towers, plate towers, packed towers and Venturi scrubbers. The spray tower and Venturi scrubbers we can use for removing particulate matters as well as gases pollutants. The problem is the scrubbers, the Venturi scrubbers are generally less effective in removing gases pollutants than towers. But towers, there is a problem. Towers get frequently clogged by particulate matter. Clogging means accumulation of particulate matter in the surface of the tower. So, if we are going to see the other methods or the other units, there is plate towers and packed towers. That is most and the commonly used device for removing gases pollutants. These are the equipments used for absorption method, packed tower and plate tower. Packed tower is a commonly used equipment. This equipment consists of different parts. The major parts are the tower packings, tower internals, then tower, the pedestals, padding, supporting part, liquid distributor, gas distributor, etc. Detailed figure given in the next slide. The theory or the working principle of this packed tower, liquid enters from the top of the tower and it is evenly distributed onto tower packings through a liquid distributor. The gas enters from tower bottom and distributed evenly through gas distributor device. The gas rises up against the liquid path through void of tower packing. This time, this pollutant air or the pollutants going to dissolve into that liquid, and the pure or the fresh air will get at the top of the control device, and we can easily disperse into the atmosphere. The second method, that is a tray or plate tower, is a vertical tower containing number of trays. Is often used to contact the hot gas with cooling liquid. Water is the most commonly used liquid for cooling. The theory or the working principle, a liquid enters the tower at the top and flows downward by gravity. On the way, it flows across each tray through the downcomer to the tray below. The gas enters the tower near the bottom and is directed upward through the opening of one sort or another in the tray. So the time of this moving, the time of gas moving into this liquid medium or this water medium, this air pollutant air or the gas pollutant, it is going to dissolve in that particular liquid medium. So we will get the fresh air at the top and we can easily disperse that gas in the atmosphere. This is the detailed figure of plate tower. This is a simple theory. This liquid is coming from the top and is going in the bottom of that control device. At the same time, gas is coming from the bottom and it is going to pass in that packing device or absorber or stripping column. And this gas the fresh gas we will get at the top of the control device. These are the common absorbents used in solution form to remove the gaseous pollutants from the gas stream. We can see the first column, that is gaseous pollutant, that is sulfur dioxide, nitrogen oxide, hydrofluoric acid, H2S, etc. And the common absorbents are there. And water is used as the common absorbent. The removal is restricted only to a few inorganic gases, that is such as ammonia, chlorine, and sulfur dioxide. So these are the common absorbents used in our absorption process. The next gas absorption equipment, Venturi scrubber. In this Venturi scrubber equipment, gas and the liquid, the pollutant gas and the absorbent flow in the same direction. The absorbing liquid is introduced at the throat of the Venturi and the dispersion of the liquid is accomplished by high velocity gas stream. That resulting large interfacial area makes the Venturi scrubber an extremely efficient absorber. However, the energy required for the achieving high efficiencies is considerable. Then if you are going to compare the gas absorption equipment, most popular one is that is packed tower one. That equipment is most popular one. The next gases emission control technique, that is adsorption by solids. Adsorption is a phenomenon by which gas or liquid molecules are captured by and adhere to the surface of the solid absorbent. So this solid absorbent is a porous nature structure. So the effluent gases are passed through the solid, and this equipment consists of a packed bed of some absorbent material. The commonly used absorbent materials are activated carbon, activated alumina, silica gel, molecular sieves, etc. So that way we are going to attract or collect the gas pollutants into this absorbent bed. Then after that we are going to remove that gases, the collected material from that absorber by raising the temperature of the granular bed above the boiling temperature of the pollutant, or decreasing or reducing the pressure of that absorbent. So in that way we can remove that pollutants from that absorbent. The working principle of this absorbent or fixed bed absorber, the gas is first enters in the solid bed. The front portion of the bed absorbs the pollutant gas very rapidly, and little amount is going to taken by the deeper layer of the bed. And the gas is initially leaving the bed is almost completely free of the pollutant. Then after some time, or after a period of time, the layers of a solid at the entrance becomes saturated with the absorbed gas, and the zone of active absorption moves deeper into the bed. Finally, when the front of the active zone reaches the bottom of the bed starts becoming inactive, and the pollutant level in the exit gas stream starts to rise. Then we can start this type of absorbent technique are widely used in the field of odor control for removing small quantities of pollutants present in a large volume of air. The working principle of this fixed bed absorber, the gas first enters into the solid bed, and the front of the bed absorbs the pollutant gas. Then the little amount will go to the deeper layer of the bed. Initially, the gas initially leaving the bed is almost completely free of the pollutant. After a period of time, the layers of the solid at the entrance become saturated with the absorbed gas, and the zone of active adsorption moves deeper into the bed. Finally, when the front of the active zone reaches the bottom of the bed and the bed starts becoming inactive, the pollutant level in the exit gas stream starts to rise. Commonly, these type of techniques are used in the field of odor control. If we are having an odor or the smell existing in this gas, we can use this method. So these are the points included in this adsorption by solids. You can see the systematic arrangement of adsorption bed or the absorber. Here we can see the second figure. There is a carbon bed is provided as a absorbent. The dirty gas we are going to insert at the bottom of the chamber, and it is going to insert in that carbon bed, and we will get the clean gas at the top of that inlet.